So, get this. Our solar system just had another visitor from way out in deep space. In this one, it's totally rewriting the rules. We're talking about a comet from another star, and its chemical signature is, well, it's unlike anything we have ever seen before. So let's dive right into the incredible story of this mysterious traveler, 3I/Atlas.
Okay, so to really get why astronomers are so excited, you've got to understand just how rare these encounters are. I mean, look at this. Back in 2017, we spotted Oumuamua. That was the weird cigar-shaped one, remember? Then in 2019, we met Borisov, which looked a lot more like a classic comet. And now, 3I/Atlas. That makes it only the third confirmed visitor from interstellar space. Each one is just this precious, fleeting opportunity to peek into another solar system.
All right, let's rewind and start at the beginning. Seriously, the story of 3I/Atlas kicks off like something out of a cosmic detective novel, with this sudden, mysterious intruder showing up in our cosmic backyard.
So picture this. It's July 1st, 2025. Down in Chile, this automated telescope system, it's called Atlas, which is perfect. It's just doing its job, scanning for dangerous asteroids, and suddenly it flags this faint, fast-moving little dot. But what was the first clue that this wasn't just another rock? Well, it had this faint, fuzzy glow around it, a thin little dust coma. And you know what that means? That's the classic telltale sign of a comet.
But right away, it was clear this wasn't just any old comet. Nope. Astronomers quickly realized they were tracking a cosmic bullet, something moving way too fast. So, a global investigation just kicked into high gear to answer the one question on everyone's mind. Where in the galaxy did this thing come from?
So how do you even know something isn't from around here? Well, the key, the absolute dead giveaway, was its path. This thing was on what's called a hyperbolic orbit. Now don't worry about the fancy name. Just think of it like this. Our planets are on a leash, right? They circle the sun over and over. This comet, no leash. It came screaming in so fast that the sun's gravity just couldn't capture it. It was like a slingshot, just whipping right through our system and heading back out. And that right there was the smoking gun. It was definitive proof this was a visitor from another star.
And when I say fast, I mean unbelievably fast. 3I/Atlas was just tearing through our solar system at about 210,000 kilometers an hour. For my friends in the US, that's a staggering 130,000 miles per hour. I mean, just try to wrap your head around that. That is way, way faster than any comet we've ever found that was actually born here in our own solar system.
And figuring this thing out was a massive team effort. I mean, check this out. It all started with the ground-based telescopes. They made the initial spot and started tracking it. Then, the legendary Hubble Space Telescope swooped in and gave us these crystal-clear images confirming, yep, it's got a tail, it's a real-deal comet. But the biggest secrets, the real juicy details, well, those were unlocked by the James Webb Space Telescope. It's the only one that could actually analyze its chemical makeup, what it's made of.
And this, my friends, is where the story takes a really fascinating turn. Because what Webb found, it wasn't just interesting, it turned this whole thing into a profound scientific mystery.
So, using one of its super powerful instruments, Webb basically peered into the gases that were boiling off the comet's surface as it got closer to the sun. And the chemical fingerprint it saw? It was completely shocking. It just didn't match anything we've ever seen that's native to our solar system. Not even close.
Okay, look at this. This is the big reveal. You see, comets in our solar system, they're mostly made of water ice. H2O. Sure, they have some carbon dioxide, CO2, but it's usually just a minor ingredient, maybe around 20%. But 3I/Atlas, it was the total opposite. It was overwhelmingly dominated by carbon dioxide. We're talking a ratio closer to 80%. This was a CO2-rich comet. We have never seen anything like that before. Ever.
So what in the world does that actually mean? Well, it tells us a story about where it came from, about its home. This comet must have formed in a place, a planetary nursery that was profoundly different from our own. Maybe it was way, way colder out there, which would let CO2 freeze out more easily than water. Or maybe it was just swimming in a lot more radiation. It could have even formed around a totally different kind of star, like a red dwarf, which are super common in our galaxy.
You see, this discovery is way more than just a cool cosmic curiosity. This little comet, it's basically carrying a message in a bottle, sent from a distant star system. And figuring out how to read that message, well, that has huge implications for everything we thought we knew about the galaxy.
And NASA scientists have the perfect way to describe this. They call these things frozen time capsules. And that's exactly what 3I/Atlas is.
It's a pristine little fragment left over from the birth of another solar system. It's been drifting through the cold, dark emptiness of space for millions, maybe even billions of years before it just happened to wander into our neighborhood.
And that's not just me saying that. The experts on the front lines feel the exact same way. Dr. Karen Meach, she's an astronomer who's been at the heart of studying all 3 of these interstellar visitors. She literally called it a gift. Think about that. It's like a free sample of the building materials from a whole other part of the galaxy delivered right to our doorstep. How cool is that?
So this is the so what. This is why it all matters so much. It's a pretty straightforward process, really. First, you analyze its chemical fingerprint. Then you compare that to our own comets. And from there, you start to piece together a bigger galactic picture of how planetary systems form and evolve all over the place. But it all funnels down to that one massive, profound question. Are the building blocks of life, are they common out there in the cosmos? So, as 3I/8less finishes its cosmic flyby and starts to fade back into the blackness of deep space, it leaves us with this really exciting question. What's next? Because its visit has given us an incredible glimpse into the future of hunting for even more of these interstellar messengers.
And the most amazing part? We probably won't have to wait very long at all. There's a new generation of incredibly powerful telescopes coming online, especially the Vera Rubin Observatory, and it is set to be an absolute game changer. Just imagine, instead of being lucky to spot one visitor every few years, we could start finding dozens of them every single decade. A whole new era of what you might call interstellar archaeology is about to kick off.
When you boil it all down, what this teaches us is a simple but truly profound truth. Our solar system, it's not some isolated island. Not at all. We're part of this vast, interconnected galactic neighborhood, where stuff is constantly being swapped between star systems.
And that just leaves us with this incredible question to think about, doesn't it? If 3I/Atlas was this weird and surprising, what other kinds of travelers are out there right now, journeying through the void, just waiting for us to find them? Because if this one little cosmic encounter has taught us anything, it's that the universe is absolutely full of travelers. And we, here on our tiny blue dot, have only just begun to crack open the door and say hello.